2.2 unit circle. So let's review some trig functions. So please recall that the sine of theta is the opposite side over the adjacent side. Cosine is adjacent over hypotenuse, tangent's opposite over adjacent. And then the following three functions are reciprocal functions of the first three. So sine and cosecant are reciprocals of each other. They go together. Cosine and secant go together. And then tangent and cotangent go together. They are reciprocal functions. All right, so we are going to use this idea and then the unit circle that you see to the right to find 6 trig ratios of triangles in the coordinate plane. So first of all, let's talk about the unit circle. The unit circle has the center at the origin at 0, 0, and the radius of 1. So that is the equation for the unit circle. I have this labeled in radian, but I'm going to also label in degrees. So 0 degrees, this would be 90 degrees, 180 degrees, 270 degrees, and then 360 degrees as we roll back around. Okay, if I want to evaluate a point on the unit circle, if it's on the x-axis or the y-axis, I have ordered pairs that I can look at. Points on this circle, when I label them, they are labeled xy, just like normal, right? So this point 0, 1 is xy, but I also know that there's a trig ratio that matches that. So let me show you. I'm going to draw a triangle whose point is xy. I don't know really what it is. That's okay. But I do know that this distance is my x distance because it's on the x-axis. And I know that this distance is my y distance because it is up and down distance, which would match with the y-axis. Well, let's talk about the 6 trig ratios from here. If I put theta here, and theta will always be drawn between the terminal side and the x-axis. All right, so we'll always be drawing back, and I'll talk about that in just a second. But as I look at this from this angle, if I want to talk about the sine of this angle, I want the opposite side, which is y, over the hypotenuse, which would be 1. Cosine would be adjacent over hypotenuse, and tangent would be the opposite side over the adjacent side, so y over x. All right, so this is true for any ordered pair. I can think about this as cosine theta, sine theta for any ordered pair on this unit circle. So that means at all of these spots, I can tell you sine, cosine, tangent, and then of course we can do the reciprocals of those, right? Absolutely we can. All right, so let's grab one of those and do it just real quick. So let's find the 6 trig ratios. Let's go with 180 degrees. So 180 degrees, we're going to do the 6 trig ratios. All right, so I'm going to go ahead and write 180 in here in these spots. And you could put pi if you want to, scrunch it in there. I'm totally fine with that. All right, so at 180 degrees, I see I have the ordered pair -1, 0. All right, I know the distance to the left, or my x distance, is -1. Cosine is my x distance, so I'm putting -1 for cosine. Sine is my up and down distance, that's y, so we didn't go up or down any to get there, did we? 0. Tangent, remember, is y over x. So this is my y, this is my x, this is going to be y over x. So y over r, remember our radius is 1, that's why it's just y. So y over x would be 0 over -1, which would be 0. All right, so now let's do the reciprocal functions. Cosecant of 180 is 1 over 0, which is undefined. I'm not going to be able to get that on there. Maybe I can move over just a little bit. All right, I'll get undef on there. All right, secant of 180 is a reciprocal of -1. So 1 over negative 1, which is still negative 1. And then cotangent of 180 degrees is the reciprocal of tangent, so negative 1 over 0, which is undefined. All right, so that's how you do those on the unit circle. Okay, let's do a special triangle on the unit circle. So I have two special triangles from geometry. We had a 30-60 right triangle, and the ratio of those, you might remember this, was 1/2 square root of 3 over 2 and 1. 1/2 goes opposite 30. Opposite 60 is square root of 3 over 2, and opposite 90 is 1. I'm going to keep that hypotenuse at 1 because we're in the unit circle. And remember, the unit circle, the radius is 1. All right, 45, 45 right triangle. Do you remember that the legs were the same length? So we had square root of 2 over 2, square root of 2 over 2, and 1. All right, so I mentioned just a minute ago that as we draw these triangles in the coordinate plane, that we will always draw back to the x-axis. So if this one is some degree, I will stop on that terminal side, and then I will drop back to the x-axis to draw my right triangle. If I'm in the third quadrant, there's my terminal side. I will move up to the x-axis, draw my line up to the x-axis to get my right triangle. If I'm in quadrant 4 with the terminal side, I'll draw back up to the x-axis. So think of it as a bow tie. This is what your triangles are going to look like in the first, second, third, fourth quadrants. Okay? All right. So let's do the 6 trig ratios. Let's go for 135 degrees. So remember, this is 0 degrees, 90, 180, 270, 360. So I'm going to go 135 degrees, which would be somewhere between 90 and 180. All right, let's see if we can figure out how much this angle is. So 180 minus 135 would give me this little piece right here. So that's 45 degrees. So I have a 45 degree, it's called a reference angle, 45 degree reference angle. And I know the sides of my triangle in a 45, 45 right triangle. I know the hypotenuse is 1. I know the legs are square root of 2 over 2. Now, I want you to think about we're in quadrant 2. X is negative, Y is positive in quadrant 2. Got it? Now we can do our 6 trig ratios. I'm just going to have you do 3 right now. So I want to do sine of 135 degrees, cosine of 135 degrees, and tangent of 135 degrees. So sine of 135 degrees, starting from this angle, opposite side. So this would be my opposite, this would be my adjacent, and this is my hypotenuse. Remember, sine is y over r. So that's another way to think about it. I want this y distance. So that would be square root of 2 over 1. If my hypotenuse is 1, it's kind of nice because I can just take those side lengths. Okay, let's grab cosine. Remember, cosine is my x distance. So cosine is negative square root of 2 over 2. Tangent is dividing y over x. So I have square root of 2 over 2 divided by negative square root of 2 over 2. That's the same thing, isn't it? Those will cancel. That leaves me 1 on the top and negative 1 on the bottom. So 1 divided by negative 1 is negative 1. So there's 3 of the 6 trig ratios. We'll do reciprocals of those when I see you again, because I want to do a 30-60 right triangle to finish up here. All right, so let's take this one. let's go 210 degrees. 210 degrees. So I'm 0, 90, 180, 270, 360. So where is 210? Yes, quadrant 3, right? If I'm at 180, I want to go to 210. 210 minus 180 is 30 degrees. I have a 30-degree reference angle. All right, so looking back at my special triangles, I know the side opposite 30 is 1/2. The side opposite 60, this is my 60-degree angle, is square root of 3 over 2, and the hypotenuse is 1. Remember we're in quadrant 3. In quadrant 3, the x distance is negative and so is the y distance, right? This point would be negative square root of 3 over 2, comma, negative 1/2. Because that's the distance we go. X distance, negative square root of 3 over 2, y distance, negative 1/2 to get to that point. Okay, we're on the unit circle. Let's find sine, cosine, and tangent. I don't even have to use theta, do I? I can actually use 210 degrees. All right, so sine of 210 is the y value over the hypotenuse. So negative 1/2 over 1 is just negative 1/2. Cosine is the x value over the hypotenuse, so negative square root of 3 over 2. And tangent is y over x. So tangent's going to be positive there, isn't it? All right, let's rationalize this. Let's simplify and then rationalize. So I'm going to multiply by the reciprocal to get that gross thing off the bottom. So my negatives are going to cancel out. Got rid of those. And I'm left with 2 over 2 square roots of 3. I can reduce the 2's. Now I'm left with 1 over the square root of 3. And then I can rationalize. So I end up with square root of 3 over the square root of 9, which is the square root of 3 over 3. Right? So tangent of 210 is square root of 3 over 3. So there are 3 of my 6 trig ratios, and we'll find the other ones when I see you again. All right, so it doesn't matter what quadrant we're in. Those special triangles, we'll draw those back to the x-axis and then label the sides. All right? I know it's a lot. See you guys soon.